Good afternoon and welcome to Design Master Training. My name is David Robison. Today we are going to be looking at Photometrics in our Design Master electrical software for AutoCAD. If you're attending the training live, you can ask questions using the chat box in Blizz. If you're watching a recording of the training, you can call or email with questions. Our phone number is 866-516-9497. And our email address is support@designmaster.biz. So let's get started taking a look at Photometrics in Design Master Electrical. We can do Photometrics two different ways in our software. We've got the point-by-point Photometrics, which are useful for it was originally written for kind of outdoor like site lighting, but the people have prompted us to get it working better for indoor calculations. And then we can also do some simple indoor calculations based upon just the area of the room. We're going to start by taking a look at the outdoor by point Photometrics. I've got a site plan here, and we're going to put in some light fixtures on this. So I'm going to go ahead and go to my electrical ribbon. And we are going to start by creating a light fixture for this project. We'll call this light fixture S for a site light. We'll walk through the settings that we have in the schedule here for our fixtures that are related to the Photometrics. I'm going to start by assigning it a block that isn't appropriate for an outdoor fixture if I can find it. The IES file is important for the Photometrics. You get those from your manufacturer's website. You can go to the lighting manufacturer. You can pull the IES file from there. The Photometrics require that you have the IES file and that you locate that. Our software doesn't provide those. We don't have a library or anything. It's too much to keep up with the manufacturers. So go to their website, find something, hopefully you can find an exact match or at least something that is close to what you're actually going to be installing. For this project, I have an IES file already downloaded. So if we press the select IES file, we can associate that IES file with the light fixture. You do get an option if you want to load the information from the IES file. Say yes to that. It's going to pull as much information from the IES file as it can. Some of the information is helpful, some of it's not. So once it's pulled in, you can then modify it and adjust it as appropriate. Something here like this description. This is kind of useful information. You might want to clean it up a little bit for your schedule. Put other information in the notes, and some of it just ends up being just content that's in that isn't as useful, so you might not want to use a note like this one here. It's all in there, and then once it's in the schedule, you just modify that as normal. The information here in this load section is going to be used for the calculation. The number of lamps is important. We have a single lamp here, so I'm going to leave that at 1. The lumens per lamp is an important value because we're going to use that for determining the output of the light, so that the IES files are always based upon a specific lumens value. But if you have a different lamp in there, you can adjust this, and then we will scale it appropriately. So we'll leave that at 40,000. That's what the light fixture, the IES file is based on. We also have an egress mode, lumens per lamp, so we can do general and egress photometrics. So if you have less light output for your egress mode, if you have not all of the lamps are turned on or something of that nature, you can have a different value here for the egress mode calculation. And then we have the lamp depreciation. This is a scale factor based upon the lamp grading over time. So you can specify something here. I'll put it at 0.9. So we'll do our calculation based upon a 90% output of that light fixture. So we like to have that called out separately just so that it's clear that you've got your lumens as one value, here's the full value, and then here's what we're scaling it to match. So those are the important values in the schedule here. We'll save all of those changes. And then we can insert that light fixture on our plan. So I'm going to run the Insert Light Fixture, select that fixture, The elevation is important because this is how far the light fixture is above the ground. So you need to set that at the appropriate elevation for your fixture. Put this up at 15 feet. You need to specify whether it is a general light or an egress light if it should be included in the calculation. If you don't check this, it's not going to be included, so it'll just be skipped over. So we'll check that as a general light. That enables the tilt and the roll. We'll ignore those for the moment and leave them at 0. Click OK. And then we can locate the light on the drawing. You'll see that it's got the contours being drawn there. That's based upon the elevation and everything else that we've specified for this light fixture, so you have some idea of the spread of this light fixture when you put it down. So I'm going to put one here, and then we can put one over here on this part of the parking lot. When the light fixtures go in, the contours are not displayed. That's a setting in options. You can have those displayed all the time or not. If you have them all on, it does tend to get a little bit messy. So the default is to display them while inserting the light fixture and then to turn them off after that, just because it makes the drawing a little tricky to read. If we query this light fixture, in the bottom right-hand section is all of the information that we're using for the photometric calculation. This is where you can go and verify that what we're doing in the calculation is based upon the right information. So again, we've got the checkbox of the general light saying include this in the calculation. It lists the lamp depreciation. It tells you what the lumens set in the schedule are and also what the lumens in the IES file are. So if they're different, we'll do our scaling based upon those. So you can check to see what numbers are being used. And then a little note here, the IES file is valid, meaning it found the IES file, it read it in, it was able to read it, that you didn't get a bad file from the manufacturer. It doesn't happen very often, but occasionally you do get files from the manufacturers that aren't together right, and then our software can't use them. I'm going to go ahead and insert an area to do the calculation. So this is in the point-by-point photometric section. I'm going to run the insert general calculation area command. Bunch of options here. We're going to ignore them all. Just click OK, and we're going to put in our area, and it prompts us for a place to in a schedule. So we'll put that schedule in over there, and then we can run our calculation. Again, a bunch of options. We will ignore them all. Just click OK. We do that, and it's hopefully showing us where our schedule is in case we've lost it. But it calculated the foot candle levels at each point, and you can see it put contours in for us. So these two lights don't overlap at all, so the contours matched pretty much what they looked like when we were inserting it. And of course, if you make any adjustments, the calculation will update. So if we take this light fixture here and we move it so it's closer, it won't update automatically. You do have to run the calculation a second time, and it'll redo the calculation. So now we've got the light for those in that area based upon those two light fixtures. So now we have a bunch of options that I had skipped over. So let's go ahead and go back and take a look at what those options were. We can run the photometric query command and select this boundary here. And we've got all of the options listed here. So we can just walk through these. The schedule title is the title for this schedule over here. So if you want to use a different title, you could override that. So I'll just change that. Call it new title. Click OK. It'll update it for you. So there it has a different title on that schedule now. The schedule, by the way, is showing the uniformity ratios. Different jurisdictions are looking for different things to be displayed. You can display the average foot candles, the max, the min, and then a couple different ratios. All of these values are based upon light, the foot candle values that are being displayed. So it's based upon the whole area. So the maximum is just the largest we find. The minimum's the smallest we find. If there are areas that are being calculated that you don't want to be included, you can either mask them off with our mask command, which is here, which will remove the from being calculated. You can also just make boundaries smaller. So if you're calculating an area and you don't want to include those numbers, make your boundary smaller so that they're not included. Going back to the settings for the boundary using the Photometric query command. The grid spacing is how often we do the calculation for the foot candles. The smaller the number, the more numbers, the more calculations you do, and it takes longer, but you get a more precise calculation everywhere. So if we take this from 10 up to 15, click OK, and then run the calculation again. Turn off the zooming to that schedule. It'll redo the calculation, and so the foot candle levels have spread out a little bit. So you just need to make sure that where you're calculating the numbers, distance between you're using is appropriate for your jurisdiction, and then also not too small such that the calculation will finish in a reasonable amount of time. That's because if you calculate too many points, it will take a very, very long time to do that. We have an option for the calculation elevation. This is where we are actually doing the calculation. So right now it's at 0, so at the ground level. If this was indoors, you might put this at, say, 2 feet 6 inches, kind of workspace height if you want to see what the light levels are on the desk for the people. If you have an area that's raised relative to something else, you could calculate the elevation up higher. So currently we're at 0. If I put this up at 5 feet, you'll see that our spread is smaller because we're basically up closer to the lights, but we're actually getting more light on all the areas. So we've moved the calculation area up relative to where those lights are. And then finally, we have area has a ceiling or area has walls. These are useful for when you're doing these calculations inside. If you have a room and you've defined the room boundary, if you check it having a ceiling, you'll get reflection off the ceiling if you've got a light below the ceiling. And if the area has walls, then you won't have the light spilling in to the other areas. I'm going to reset my calculation elevation to 0. Click OK. And I'm also going to put in a new area. And we are going to leave everything as it is right now. And I'm going to put it in over here to demonstrate a couple things there. We can do the schedule separately or together, so we could get the uniformity ratios for everything together or each area separately. And I'm going to move this light fixture so that it's right here at the boundary. So this light should now spill into this area. So if we run the calculation, when you run the calculation, if you have multiple areas, it'll prompt you. You can calculate one area or press enter and it'll calculate both. Here we've got 2 areas with different grid spacing being calculated. So that's, if you have an area where you need a different grid spacing, which sometimes does happen, you can set it up this way. And now if we come in to this one and we say this one actually has a wall, and we're going to put it up at 20 feet, so it actually is higher than that light fixture. We now have no light in this area because this is a wall, and so all of the light is being blocked. So if this was indoors and you actually did have walls, that would be the way that you can have the light obstructed between the 2 areas. So I just wanted to demonstrate how that feature worked. Not terribly appropriate for this specific example, but if you're working indoors, that's what that's. Go ahead and turn that off. So that when we run our calculation, we have that in there. In the calculation, we have a number of different settings that you can adjust. On the left-hand side, we have the contour levels, so you can see the cutoff for specific candle levels. We have it set to 0.5, 1, and 2 foot candles currently. And add and adjust more if you want to here. And the more numbers you give, the more contours you'll get. You can adjust the color as well if you want to have different colors just for color coding purposes to see where they are. I'll change that one to red. Click OK. Press enter to calculate everywhere, and it'll do the calculation with those additional contours. And the red one here for 10-foot candles is over here. Running the calculation, again, we have a couple more options on the right-hand side. We have a checkbox to show the foot candle levels. You can turn those on and off. And then the contours, you can turn those on and off separately as well. So if we uncheck foot candle levels in the calculation, no foot candle levels, just the contours. Flip that, we'll turn the foot candle levels on and the contours off. So those are just checkboxes to control what's actually displayed in the output. We have the option for the decimal places on the drawing and then in the schedule. On the drawing refers to the foot candle levels that are being printed on your plan. In the schedule is over here in the schedule, because you'll see that we've got a single decimal here, but we go out to 2 decimals a couple places over here on the right-hand side in the schedule. So you can adjust how much precision you show. So we could increase those to 2 and 3. Now we have 2 decimal places here, and then we go to 3 decimal places over here. So that's how you can control the precision of the values being displayed. Go back to 1 and 2. We have the option for the base unit for your plan. Typically, this is going to be inches because most of our customers are working with inches. If you have some civil plans use the base unit as a foot, and so if it is, then you need to adjust this so that all the calculations and distances are right. So you just need to know if you are working with a drawing that has a base unit of an inch or a foot. If you do a calculation and it looks terribly off, you can just change it and see what happens. If it's taking a long time, you can also change this, and often switching from inches will up because you have the wrong unit chosen. So it's important to get the right unit selected there. And then we have the option for reflections, which will calculate the reflections off of walls and ceilings. It takes a little bit of extra time, which is why we have it as an option to turn it on or off. A lot of times it doesn't have a huge impact on the calculation. I'll go ahead and demonstrate that. I actually need a wall to reflect off of. So we will just rerun that calculation. I'm going to put a wall in here. It's just going to be a solid line for the moment. You can set the reflectance for your solids, and so that's going to be used to calculate the reflection. We'll leave it at 0.5, and I'll put this wall here. So it's now pretty close to these points, and we should see these numbers go up if we turn on our reflections. We'll change reflections. Actually, we'll run it first with none. So that's the numbers we're getting. I just wanted to make sure that we're seeing the right value. I didn't know how much this light was going to impact it, because now that light fixture is not shining because the wall is blocking it. Turn on the single reflection, click OK, run the calculation, and you see that that 9.7 went up to 17.7. So you've got this wall right next to the light fixture. It's reflecting a fair amount of light, so your numbers are going up. Alternatively, if we move this wall over to here, we've got 1.3 foot candles at this point coming from this light fixture. When we run this calculation, this 1.3 is not going to go up very much. In fact, it stayed at 1.3. So just there's not enough reflection happening at that distance from that wall to have an impact on the calculation. But it is being calculated, but just not actually having any impact on the final output. The final thing here is we have the settings for these schedules. We can adjust which columns are actually being shown, so you can choose which ones you want to display. Typically, you'll want to check the boxes for what your jurisdiction is requiring you to display. And then you can also adjust the sizing of the schedule based upon these two width values. So if we wanted to, we could get rid of a couple columns. Now we've got the shorter schedules. The schedules can be grouped. So we have these calculation area groups where you've got multiple groups being put together in a single schedule. So right now, this area refers to this schedule, and this area refers to this schedule. If you wanted to have those combined, a single schedule for both of them, you group them. So we can add the calculation areas together. Say, okay, we want to use this one, and we're going to add this boundary to that other one, so we'll keep this schedule. And if we run our calculation again, it'll up this schedule. The new values based upon the new maxes and mins and the two areas together. Turns out they're pretty similar. I think most of the maxes and mins were over here, so the numbers didn't change much, but they would and they do include both values. All of this so far has been done on these flat areas. We also have the ability to insert a sloped area. This can either be a slope if it's actually outside and there's a slope. This is also how we recommend that you model stairs. So if you have a stairway in your building and you want to know the light fixture level, the foot candle levels on that stairway, rather than modeling each stair tread, just model it as a slope. And for your foot candle calculations, that's going to be sufficient in most cases for knowing if that stairway is lighted well enough or not. I'm going to stretch this one out of the way so we can put our stairway right here, our slope. So when you do the sloped area, you get an additional option. In addition to just a single elevation, you now have a top and a bottom elevation. So we're going to go from 5 feet down to 0 feet. Click OK, and then you specify basically a drawing across a box. You want to specify where the top of the area is. So our 5 feet is up here. Our 0 is down here. And then it wants to know the width of the area. So I'll draw the width like that. And it puts it in for you. And then you have the option to do an area calculation schedule here, or I can click here and add it to that group. You notice that it has some width to it, thicker up here, saying that, okay, this is the top, and then it's thinner down here, indicating that that's the bottom of the slope, to give you some visual indication as to where your slope is happening. And then when we run the calculation, we get different values because we have the slope happening there. You'll notice that we're getting all of these light fixture values inside our building. You typically wouldn't want that. You actually want that building to block the light. To do that, we saw it before with this line, but we have a number of commands for inserting solids that will block the light. So if I actually choose a shape, you can specify the elevation of the shape so that it knows what to block, and then you can trace it out. And everything that is inside this shape will be ignored in the calculation, and it will actually be masked out, so it won't list all of these zeros anymore. Move this light fixture up closer so we can see that it's clearly blocking the light. I'm going to put it here so we can see that it's going to cast a shadow over here as well. In the calculation, and you can see, okay, inside the building, it's not listing the foot candle levels at all because the building goes down to 0, so it knows you don't really care about those. And then obviously it's blocking the light going this way because the building's in the way. If you have an overhang, you can model that. A rectangle with a starting elevation that's not 0. So say we have an overhang at 10 feet, do a starting elevation at 9, ending elevation at 10, so it's a little 1-foot overhang. It's blocking some light, so we have a little bit less light here because the overhang's in the way of this light fixture. In the same way, if you want to model trees or anything, you can do them again with solids. We don't have anything more sophisticated than just like a true solid. So, depending on how much you think that tree is going to be impacting the light, you can mess around with what your actual solid's going to look like, how much you actually want to block the light from it. But when you're drawing the solids, you can do a single line, a rectangle, or just a shape, depending on how you want to draw it out. We can also mask the foot candle levels. That's if you just want to not display the values in a specific area. If I draw a mask around here, it'll just exclude those 3 values. It's not otherwise going to block light or anything else. So if we run the calculation again, It's just not including those values. So if there's an area that you don't want to display the foot candle values, if you got a donut shape or something, you can block out the middle of your area. And then we've got two commands here just for adding and removing vertices on these if you want to adjust them. Because once they're in, you can use standard AutoCAD grips to adjust them. They're just polylines, and software knows to just use the shape of that polyline. But if you need another grip, you can put that in using the vertices commands. The other command of note here is the Aim Light Fixture. This allows you to point the light fixture at a specific point on the ground. It will both rotate it and tilt it, kind of in one step. So if you want to, you can just rotate it, and it will work just fine. If you need to tilt it to point it at a specific spot, you can adjust the tilt when you query it, or you can click on a spot. So if I point this light fixture here, it will figure out the rotation so that it actually tilts and points directly at that location. So if we query this, you can see that this tilt has been changed from 0, pointing straight down, to 65 degrees. So that's what it needs to point it at that spot. And then if we run the calculation, again, it adjusts to be pointing there. So we've got all the light going forward over to this point, nothing or much less going behind it. We're looking at all of the general commands. We have the same for the egress. And so the difference there is that when it's doing the calculation, instead of using the general lumens value, it's going to use the egress lumens value. So that's the only difference between the two. So we have that option if you're doing egress photometrics, particularly egress and general photometrics, Aim Light Fixtures. And that is an overview of how the point-by-point photometrics work. We also can do our simplified indoor photometric calculations. And here we're using a room cavity ratio calculation to calculate the average foot candle level for a room. So rather than do ray tracing and figuring out the foot candle level at each point, we're just taking basically the light output from all the light fixtures, lumens, times the coefficient of utilization, which is calculated based upon the shape of the room and the reflectances in it. And then multiplying that by the depreciation factor, you divide the whole thing by the area, and that gives you the approximate amount of lighting in a room. It used to be this was kind of a standard calculation because it was easy to do and it worked fairly well. More and more people are doing the point-by-point calculations because computers are faster than they can. So these two methods end up with similar but not exactly the same numbers just because they're approaching the calculation in a very different way. But the way you can do that with our software is you start by inserting your light fixtures, which we've done, but then you actually need to insert some rooms. You can create a room. The room type is going to adjust the various reflectances. Those are being pulled from our room schedule, so you can modify those if you want to. I'm going to create this room, trace it out on the drawing here. And this label here will show you all of the values being calculated. So the actual foot candle levels in this room is 52 based upon, again, the light fixtures that are being inserted in there. It's not as precise a calculation as the point-by-point. If you just want the general lighting area, this will give it to you. Lighting level, this will give it to you. So that will give you the values for each individual room. You can also insert a schedule that will list each room. So here under light fixtures, insert your lighting level report. This lists each of your rooms and all of those other values. So you can see your actual foot candle level being calculated for each room, and then the numbers being used to calculate that. The room cavity ratios, the coefficient of utilization, and then some other values based upon the watts and the total watt in the room. And that's how the indoor lighting calculations work. They're quite a bit simpler than the point-by-point calculations that we can do. All right, so the first question is linear LED lighting is getting more and more popular. You can often order custom lengths of light, but the IES file is set up for a specific length, such as 4 feet. So if you have 12 feet of light, how do you best model that with the software? And the answer is that you need to have a single light fixture for the 4 feet representing the IES file. And then if you have 12 feet of light, you just put 4 of them or 3 of them back to back to get the 12 feet. So we don't have any way to have, adjust to have a single fixture and say, okay, this one fixture is 8 feet long, but we need to do IES file in here twice for it. Just create it as a 4-foot section, put in as many as you need, and then the calculations will be based upon that. The second question is there a way to get the IES file to associate with the center of the fixture instead of the insertion point? And so the IES file will associate with the center of the fixture as defined by how, so in the block definition, you can define how loops connect to a fixture, and we actually piggyback off of that to figure out where the center is for doing the IES file. So we put it at the center of where the loops are being connected. And then you also have the option with the arm length to adjust that a little bit. So let me walk through that to demonstrate how that works. See, if I go here and I'm going to make a new light fixture. I'm going to make a 2x4. Sure, I'm going to select, let's see if I've got the right box. Okay, so we've got this 2x4. So actually we'll demonstrate it well. So we've got this option, the pendant mount. Put in some lumens here. Associate an IES file with that. A B. That's going to be my recessed fixture. So we'll come here and we'll put these 2 light fixtures in. All right. So when you have your loops, they are connected to something, and so the center of the IES file is at the center of where these loops are connected. So on this fixture, the IES file is actually centered here, which is not the best spot, honestly, for this one. This one has a nice box, and the IES file is centered at the center here, not the insertion point. So if you have a block and you need the IES file to be somewhere other than the insertion point, a way to do that would be to have the loops connect to a different location. My other recommendation would be that you could redefine the block so that the center of the insertion point of the block is where the IES file should go. That might be another option for making that work. And then finally, we have the option for the arm length, and I'm going to demonstrate that with this fixture here. So currently, it's the insertion, the IES file is centered right here. But if we actually had an arm and we wanted to push it out a little bit, we can go to the schedule, and there is an arm length option. So I could change that from 0, say we've got a 10-foot arm, just to make it actually look like something happens. So that's going to push this whole calculation from this point out 10 feet in the direction that the light fixture is pointing. So if we run our calculation again, everything got pushed out forward this way. So now it's as if the IES file is located right here. The options that we have for changing where that IES file, where the calculation is happening if it's not directly in the insertion location of the light fixture. From the mailbag, how do I insert panels on multiple sheets? Or in this case, we're going to look at how do you insert panels in multiple areas. So we have these panels here, and they are on the power plan. And we also want to show them over on the lighting plan, just so that in both areas you can see them. If you make a copy of them, erases it. It doesn't actually let you copy it because the way our panels and all our distribution equipment works is that when you do the copy, it doesn't actually make the copy. You have to do the copy through our standard distribution equipment stuff, and that would make a second one. You don't really want a second one. You want the same thing, just shown in a different spot. So instead, we have the insert plan view blocks in another area or drawing command, which is specifically for this purpose. You run that command. You select the pieces of equipment you want to insert. And then you select the area. So if you've got multiple areas, you select it. If there's no area, if there's only one area, it'll just go in that area on the drawing. So I can select the area over here. And so based upon the location of this alignment point and this one, it says, okay, these ones are here in this area. And then over here, we have the same alignment points, so we get them in the same spot. So now we have the panels in both areas being displayed. If you move them in one area, they will actually update in the other. So if I go here and I move this L3, if I'm going to pull it all the way down to this other room, see that it pulled it down in this other area as well. So they are nicely linked, one area or one location in the drawing being displayed. So panel being shown two places, and it keeps them updated. It works in a single drawing, and it also works across multiple drawings. So if you had a lighting drawing and a power drawing, if you move it in one, it will actually, the next time you open the drawing, it will move it for you automatically. So it keeps everything nicely linked. And there's the comment that works well also if your panels are on the first floor and you need to line them up with stuff on the second floor. Yeah, so this is not limited to lighting power. If you have them on the first floor and you just want to show them on the second floor, you can do that as well so that you can get things lined up nicely. It also works in a site plan, so if you want to show them on the site plan, you can do it there as well. Another question we've gotten is, how do you handle spare breakers in the software? And there's a couple different ways you can handle it, depending on what you're actually looking for and how you want to handle it. In the panel schedule, by default, list everything as a space. In the circuiting dialog, you can select one of those spaces and change the description to spare. And so it'll go from space to spare. So that's one way you can get that to happen. I also have an option for what the default circuit description will be. Here in the circuiting load types and wire sizes, the unused circuit description. Currently we have space with breaker size listed, so you can do space and spare with and without the breaker size. So I could change that to spare with breaker size listed. And now every circuit that's empty will be listed as a spare breaker rather than a space. So that's how you get those in the schedule show up. Then there's the question on the one-line diagram. How do we get them to appear? The answer is that they're not going to be inserted automatically. You have to insert them as a second additional step. If I make this panel bigger so I have a spot for them, the insert feeder command, you run that command, and you can just put in a feeder. It's not going to be connected to anything. It's not really linked to anything in the database, but you can use it to show the spare feeder or the spare breaker. We just have that drafted in using all of the layers and blocks to match everything else. If you go and put labels on it, it's not linked to anything, so it doesn't have any labels by default included with it, but you can add some labels to it. So we could say spare here. We could give it the size. Do something like that. Now again, that's not linked to anything else. It's the linked actual spare breaker in the schedule. So that is a place where you do have to keep them synchronized a little bit. Thank you for watching today's Design Master training. If you have any questions in the future, feel free to contact us by phone or by email, 866-516-9497, or support@designmaster.biz.